So the question we are answering is for 2018 MT1 question 4. Okay. So before we answer this question, let's answer a simpler question. Okay. Suppose I get rid of all those plus and minus. Is the question simpler for you? Basically, if I change the question to this, would that be simpler? Is the question clear to everybody? So for this question, how do we solve this? We find the period of the first one, which is 2 pi divided by 8 pi over 5, which is 4 over 5 pi. And we get the second period, which is 2 pi divided by 12 pi over 5, which is 6 over 5 pi. And finally, this one is 2 pi divided by pi, which gives you 2. So this and 3.
But the other periods don't have pi because the pi's cancel out. Like M1's period should be 5 fourths.
Oh, yeah. 5, yes, you're right. Thank you. So the pi cancels out. So the question is, what is the period? So no, it's actually not the period. So M1 is, if it's continuous time, then that's the period. But it's not continuous time. The period should be the LCM of 5 over 4 and the 1. So LCM of 5 over 4 and 1, which is 5. So the M1 is LCM of 5 over 4 and 1, which is 5. N2 will be the LCM of 5 over 6 and 1, which is still 5. So this is 5. And N3 is 2, so which is good. So the final period is going to be the LCM of 5, 5, and 2, which is 10. So therefore, the fundamental period for this signal, is 10. Is everybody okay with the solution? So that part is pretty easy. The harder part is now I have this change here and there. Is the question clear to everybody? It turns out it doesn't change much. The reason is because you can see if you look at the continuous time case, let's say cosine a pi over 5 t minus 3. If you look at the continuous time case, all it did was the continuous time is going to get shifted to the right by a pi over by 3. So it's going to move to the 3 to the right. So it's going to be, the new one is going to look like this. It's shifting to the right by 3. And the discrete time case, you are still taking everything at the integer point, because I'm taking everything at the integer point. Therefore, it's going to still show the same periodicity. To be extra clear, the new period is still the same as 5. Because what happens is the continuous time shifted, but continuous time repeats itself every 5 over 4. Therefore, I shifted, still repeat itself every 5 over 4. That's why N1 is 5. N2 is also 5. And the N3 is 2. So therefore, the final answer is still the same answer as the simplified version. It doesn't change by having a special constant. Is everybody okay with the solution? Yes. I probably will let you go. Thank you very much.